Hey, what's up YouTube? In this problem we have a triple integral.
Triple integrals are for noobs. We should do quadruple integrals.
And all we have to do is integrate, so let's go through it very carefully. So, when you're doing a triple integral, you just integrate 3 times. That's all you do. So in this case, we first have to integrate with respect to y.
That's probably a good idea.
Okay, so when we integrate with respect to y, all the other variables are constants. So we're going to treat x as a constant. So basically we have to integrate e to the negative y with respect to y. So I'm sure you know this from calculus, but if you have
Hey, where's Justin?
like e to the 2x with respect to x, you can just divide by the 2. It's e to the 2x over 2 plus a constant. You can do that as long as it's number times x, right? So here it's negative 1. So basically we're just going to get e to the negative y over negative 1, okay? But we have an x here, so this is going to become negative x e to the negative y, okay? And then we're going from 0 to ln x. 0 ln x. And we still have the dx and the dz, so we have dx, dz, and we still have these other integrals here, right? So 0 to 2z, 0 to 2z, and we have this other one here, 1 to 2. So again, when we integrate this, x is a constant, we just divide by negative 1, right? So we get that. And then now we have to evaluate this. Now be careful here, we integrated with respect to y, so these limits are y values, right? So this is y equals ln x and y equals 0. Be really, really careful when you're doing these problems. Always take your time. So I'm going to write this again. So 1 to 2, 0 to 2z. First plug in ln x, so we get negative x. I'm going to leave the x outside. So we get e to the negative ln x, okay, minus e to the negative 0, right? Be really careful. I haven't done this yet, so I'm trying to be really careful. dx, dz, right? So we plugged in ln x, looks good. Plugged in 0, looks good. E to the negative ln x, we can do some trickery with that. We can write that as ln x to the negative 1, right? You can bring a negative up, right? If you have negative ln x, it's negative 1 times ln x, right? You can bring that x upstairs, it's the power over for logs, right? And that's just going to become x to the negative 1, which is 1 over x, right? So this is going to be 1 to 2, 0 to 2z. So we have negative x, 1 over x, e to the 0 is 1, dx dz. Okay, so that just became 1 over x. Oh, look at that, look at that. Let's keep going. This is equal to the integral from 1 to 2, 0 to 2z. Beautiful stuff. Distributing the negative x. Negative x times 1 over x is negative 1. Okay. Negative x times negative 1 is plus x. And we're integrating with respect to x next, so dx dz. So again, we distribute the negative x, no big deal. Negative x times 1 over x is negative 1. Negative x times negative 1 is positive x. All right, now we're integrating this with respect to x. We just have to integrate this with respect to x and integrate this with respect to x. So we're still going from 1 to 2. We still have this one. And now we drop this one, right? So it'll be, when you integrate negative 1, you get negative x. When you integrate this, you get x squared over 2, right? Use the power rule, right? There's a 1 there. So plus x squared over 2. And we're going from 0 to z, and then we have dz. See how we did that? So we replaced the integral sign with this notation here, and now we're at dz. First you plug in the 2z, subtract, and you plug in the 0. So this is the integral from 1 to 2. Boom! Plug in the 2z, you get negative 2z. Plus, plug in 2z here, right? You're going to get 2z squared, okay? 2z squared. So 2z squared, I'll just write it, 2z squared. I was going to skip a step, let me know. Minus 0, so plug in 0, it all goes away. So no big deal, so dz. Now we're left with a single variable integral, okay? Now we're left with a single variable integral, and we'll do it. So I'm going to erase this and come back up here because I'm running out of room. So I'm going to write it again. So we have the integral from 1 to 2, negative 2z, beautiful stuff. When you square this, you're going to get 4z squared over 2. That's just 2z squared, right? So those are it's going to cancel, right? Because you square the 2, you get 4, square the z, you get z squared. 4 over 2 is 2. So you get plus 2z squared dz. We integrate this. We get negative 2z squared over 2 plus 2z cubed over 3, right? Just using the power rule. There's the 1 here you add, divide by. There's the 1 here you add, divide by. And we're going from 1 to 2, okay? Let's clean this up. This is negative z squared plus 2/3 z cubed. I think my camera's running out of batteries. It's going a little fast. And then we're going from 1 to 2. First you plug in the 2, so let's do it. So you would get negative 2 squared, right? That's in parentheses there if you really want to show extra steps. Plus 2/3, 2 cubed. Minus, and then you plug in the 1. So it'd be negative 1 squared plus 2/3 times 1 cubed. Okay? Just Plugging in the 2, subtracting, plugging in the 1. Plug in 2, we got that. Boom, there it is. Subtract, plug in 1, there it is. This is negative 4. This is plus 16, right? 16, 2 to the 4th is 16 over 3. And this is plus 1 here, plus 1, minus 2/3. Okay? So this is going to be negative 4 plus 1 is negative 3. 16/3 minus 2/3 is 14/3. So we can think of this as 9/3. This is negative 9/3 plus 14/3. And that gives us 5/3, which is the final answer to the triple integral. Thanks for watching. I hope this video has helped someone out there. Subscribe, like, all that cool stuff. Take care.